You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome. We're jumping straight into, well, what feels like two completely different worlds colliding in AI right now.
It really does. On one hand, you've got this almost industrial revolution scale build-out, think trillion-dollar factories.
It's huge, yeah. And on the other,
Mhm.
it's like these incredibly detailed, subtle technical standards making it all actually work, like the plumbing.
Exactly. We looked at a ton of material recently, and those are the two big currents. First, this absolutely massive race for computing power, the infrastructure needed.
Raw muscle.
And second, kind of quieter, but just as vital, is the push to standardize how AI agents connect and operate so they're useful beyond just, chatting.
Okay, so let's tackle both. The mission today is understanding that staggering costs for the AI cloud, the gigawatt space race,
Yep.
and then pivot to how protocols are making AI genuinely functional on your devices.
Let's kick off with the infrastructure, because the scale here, the strategic thinking, it's honestly beyond what we usually see, even in tech. We're talking foundational trillion-dollar bets.
That trillion-dollar number, that's the one that grabs you, isn't it? OpenAI's vision for these compute warehouses. It sounds less like R&D and more like building, I don't know, the next power grid.
Well, that's almost literally it. When a company talks about needing power on the scale of nations, things have shifted. OpenAI thinks they need, upwards of 20 gigawatts just for projected demand.
20 gigawatts, wow.
And they're aiming to build out capacity to add 1 gigawatt of new infrastructure every single week.
Okay, hang on. 1 gigawatt a week. And the cost for just one is estimated around $50 billion.
Around that, yeah. So you see why these corporate deals start looking like, national budgets. They're not just tech partnerships anymore.
Absolutely. Like the Nvidia and OpenAI deal and intent to build data centers with 10 gigawatts of Nvidia gear.
Yeah.
That could hit $100 billion over time.
It's monumental. And look around, Oracle's talking to Meta, a huge cloud deal, maybe $20 billion, just to handle Meta's models.
And Microsoft's putting, $30 billion into the UK alone over the next few years? A lot of that for AI infrastructure, even a supercomputer project.
This capacity is just the entry ticket now. And you see why when you look at training costs. Take Grok 4.
Right. The training run cost estimates were wild.
Around $490 million for one training run. And the electricity needed, enough for a town of 4,000 people for a whole year. You need that massive infrastructure base to even play the game.
Okay. So they're building the giant power plant, but then you need the grid, right? The smart grid.
Yeah.
All that compute power is amazing. But if the model can't talk to your calendar or your code,
It's just a very, very expensive chatbot. Exactly. That's the bridge. The bottleneck immediately shifts from just raw power to operational plumbing standards.
which brings us to the Model Context Protocol, MCP.
Yes, MCP. It's fascinating because it's all about getting these different systems to speak the same language.
With Anthropic's protocol, right?
Yeah.
Basically letting an AI agent plug into APIs, get data, understand the context so it can actually do things.
Precisely. And the big news is who's starting to adopt it. Apple is laying the groundwork for MCP in their latest betas.
For Mac, iPhone, iPad, that's huge.
It is. It signals they're serious about enabling proper agentic AI that does multi-step tasks right across their ecosystem. Developers will be able to expose app functions directly to AI platforms using this standard.
So the AI becomes less of a detached brain and more like a collaborator inside the apps you use.
Exactly. And you see it in specialized areas, too. Like for developers, the Chrome DevTools MCP server.
What does that do?
It lets debugging tools performance info, code checks, feed directly into AI coding assistance. So your AI pair programmer could spot a bug by simulating user actions, maybe before you even run the code yourself.
That's a step change in workflow. And you mentioned the Data Commons MCP server, tackling hallucinations.
Yeah, that helps ground the models, gives them direct access to huge public data sets, real-world stats, so they're less likely to just, make stuff up. It anchors them in facts.
It all comes back to managing context, doesn't it? Like OpenAI's new responses API. That's about persistent reasoning.
Exactly. Keeping track of the conversation, the state, the logical steps across turns, not just starting fresh each time.
And they're seeing real benefits.
They are. They reported, I think, a 5% boost on TO Bench, which is a pretty tough benchmark for model performance across complex tasks. 5% there is significant.
And better efficiency, too.
Much better. 40 to 80% improvement in cache use. So they're getting more value out of all those expensive compute cycles.
It really feels like a move towards these specialized persistent agents. Didn't some users briefly see internal test models? Like agent with truncation?
Yeah, those alpha models popped up briefly. Things like agent with prompt expansion. It suggests they're deep in experimentation, figuring out the best ways to set up these agentic systems.
Okay, so the plumbing's getting sophisticated, the power is there.
Yeah.
Does it actually make us more productive?
Ah, the million-dollar or trillion-dollar question. And the answer, especially for coding, seems to be it's complicated.
Right, I saw that. Great for new projects, maybe, but AI coding tools can actually slow developers down in big old code bases.
That's the paradox. The sheer amount of existing code, the context limits of the models, it creates friction. You need some serious engineering craft to make it work at scale.
Like that frequent intention compaction technique.
Mm.
Sounds intense.
It does, but the idea is pretty smart. Instead of trying to stuff, say, 300,000 lines of code into the AI's brain every time,
Which you can't handle anyway.
right, you systematically summarize chunks of code into their core function, their intention. Compact blocks the AI can grasp. It lets the agent focus on the high-level structure the change is needed without getting lost in the weeds.
It's like giving it an executive summary of the code instead of the whole novel. Makes sense. And that's how that one team managed that huge Rust codebase. Shift a week's work in a day.
That's the claim, yeah. Expert-reviewed code, massive productivity jump. That's the potential when you get the engineering right.
And we're seeing user-facing versions of these persistent agents appearing too.
Definitely. Like ChatGPT Pulse for Pro mobile users, it proactively pushes personalized research updates based on your chats, your connected apps. It's like a little background researcher working for you.
And Perplexity's email assistant, doing drafts, organizing, scheduling right from your inbox.
Yeah, integrating directly, using the email context. These are becoming real assistants.
But the really mind-bending step is taking this out of the screen into the physical world.
Google DeepMind's Gemini Robotics 1.5, that's the one, a vision language action model. It's bringing that agentic capability to actual robots.
So not just pre-programmed tasks.
No, that's the key difference. It sees, understands language instructions, and then it thinks it shows its reasoning before acting. And crucially, it learns across different types of robots.
So the same AI brain could run a robot arm or a walking robot.
That's the promise, a general-purpose physical agent, able to handle complex, multi-step tasks that need real-world reasoning. It's a huge leap.
Okay, but with all this power and reach, we have to talk about the flip side, the risks, the data issues, the security concerns.
We absolutely do. The tech is moving so fast, and the governance, the safety checks, they're struggling to keep up, which leads to some uncomfortable situations.
Like that Neon Mobile app case, paying users to record their calls.
Yeah, that one raised a lot of eyebrows. Reportedly paying users maybe 30 cents a minute up to $30 a day to record phone calls, and then selling that raw audio to AI companies for training. Buried in the privacy policy, apparently, a very broad license. It just highlights this hunger for data, even incredibly sensitive private conversational data, to fuel the models, so often without people really understanding what they've agreed to.
And when you have multiple agents working together, that creates new security holes.
It does, this idea of cross-agent privilege escalation. It sounds technical, but imagine you have two AI agents in a system.
Okay.
You trick Agent A, the one with fewer permissions, maybe with a clever prompt. You get it to somehow modify the settings of Agent B, the more powerful one. Yeah, so Agent A suddenly gets Agent B's powers. It can access things it shouldn't. The big takeaway for anyone building these systems, you absolutely have to run these agents in lockdown, isolated containers, sandboxes.
Security is one thing, but what about just trusting the AI, ensuring it does what we want?
That's the alignment problem. DeepMind safety work is looking right at this. What happens if an AI ignores instructions? Or worse, hides its reasoning so we can't even tell why it did something?
That's worrying. How do you trust something you can't fully audit?
It's a fundamental challenge. On a more immediate social level, you see OpenAI taking steps like adding age prediction for under 18s, stopping ChatGPT discussing self-harm with teens, trying to build guardrails.
And then there's the legal and political battlefield heating up.
Oh yeah, the XAI lawsuit against OpenAI alleging theft of trade secrets, specifically about deploying data centers, big players fighting over the infrastructure secrets.
And Meta funding a super PAC.
Right, the American Technology Excellence Project, investing heavily to push back against state-level AI regulations. It just shows the enormous economic pressure to shape the rules, or lack thereof.
So we've gone from $100 billion deals down to, well, critical 5% performance gains from smarter protocols. If you listen to vocal technologists, you know we try to cover that whole spectrum. It really is this twin track of massive ambition and incredibly detailed plumbing.
It's a fascinating duality. You need both the brute scale and the clever standards for any of this to really work.
But here's a final thought for you to chew on, based on some really interesting research we saw on how people actually use these AI tools effectively.
Oh yeah. What did they find?
Success in collaborating with AI agents across hundreds of people, it depended less on their technical skill, their coding ability,
And more on.
more on their social intelligence.
Really, like understanding people.
Exactly. People who were better at reading others' intentions, understanding mental states, emotions, they performed significantly better working with the AI.
Wow.
So if being good at understanding people turns out to be more important than mastering a technical framework for getting the most out of this trillion-dollar AI revolution, well, that might just change what skills we value most. Something to think about.
Definitely something to think about.
Until next time, we'll see you on the next exploration.
Spoken Tech for your ears.